The Great Red Spot. This colossal anticyclonic storm is located on Jupiter and stands as the largest and most famous tempest in the entire solar system. It is generated by the planet's intense internal heat and fueled by opposing atmospheric jet streams that compress the storm, keeping it trapped at a specific southern latitude. What makes it truly exceptional is its sheer scale and longevity, measuring wider than the planet Earth and raging continuously for at least several centuries. While recent observations show the storm is gradually shrinking in diameter, its winds still howl at speeds exceeding 400 miles per hour. It matters immensely to planetary scientists because studying its deep structure helps reveal the complex thermodynamic inner workings of gas giant atmospheres that are impossible to replicate in a laboratory on Earth. The Great Dark Spot. Discovered on Neptune by the Voyager 2 spacecraft in 1989, this massive atmospheric disturbance represents the most violent weather system ever recorded. This storm is a high-pressure system generated by the extreme temperature differences between the planet's freezing upper atmosphere and its hot, radiating core. It stands out because it produces supersonic winds that tear through the atmosphere at up to 1,200 miles per hour, making it far more aggressive than any hurricane on Earth. Unlike Jupiter's long-lasting counterpart, this storm proved to be highly unstable, completely vanishing by the time the Hubble Space Telescope checked on it a few years later, only for a new one to appear in the opposite hemisphere. This cycle matters because it demonstrates that even the most distant, ice-cold planets can harbor incredibly dynamic and rapidly changing weather systems. Great white spots. These periodic planet-encircling storms erupt on Saturn roughly once every 30 Earth years, coinciding with the peak of the gas giant's northern summer season. They are colossal convective disturbances driven by the massive upwelling of warm ammonia gas from deep within the planet's interior, creating brilliant white clouds that contrast sharply with the rest of the atmosphere. The most recent major outbreak occurred in 2010, when a single storm grew so violently that its tail wrapped around the entire circumference of the planet within a matter of months. This phenomenon is critical to planetary meteorology because its precise 30-year cycle offers a unique window into how seasonal solar heating triggers sudden, catastrophic energy releases in deep hydrogen atmospheres. Global dust storms. These massive weather anomalies occur on Mars, transforming the red planet from a cold desert into a chaotic, planet-wide sandstorm. They originate during the Martian southern summer when solar heat rapidly warms the thin atmosphere, generating powerful winds that lift fine iron oxide dust high into the sky. Unlike localized storms on Earth, the dust absorbing the sunlight creates a runaway heating loop that causes individual storms to merge until they completely blanket the entire globe in a thick, choking haze. One of the most severe instances occurred in 2018, completely blocking out the sun and ultimately ending the mission of NASA's Opportunity rover by draining its solar panels. These storms are incredibly significant because they drastically alter the Martian climate and present the single greatest environmental hazard for future human exploration missions to the surface: the hexagonal polar jet. This bizarre permanent storm system locks around the North Pole of Saturn, creating a geometric weather pattern found nowhere else in the known universe. Discovered during the Voyager flybys and later photographed in stunning detail by the Cassini spacecraft, it is a massive wave structure in the planet's polar jet stream. The hexagon itself is a roaring hurricane measuring nearly 20,000 miles wide, with a massive vortex spinning directly at its central point. What makes it truly unique is how the geometric shape maintains its rigid structure while fluid winds blow along its edges at over 200 miles per hour. This planetary anomaly matters because it challenges our fundamental understanding of fluid dynamics, showing how atmospheric rotation and wind shear can create highly organized geometric shapes on a massive scale.